Hi. In this last lecture on aggregation, we want to talk about the aggregation of preferences. So this is going to differ from what we've looked at before. Remember when we looked at the central limit theorem, we looked at aggregating numbers or actions, and then we looked at the game of life and cellular automata, we were talking about aggregating rules. Now we want to do is we want to aggregate preferences. So preferences are going to be a different structure, a different mathematical structure than what we had with either rules or numbers. So to get a handle on this, to get a handle on how we aggregate these things, first we've got to say, well, what are preferences? How do we represent them? So, well, let's think about it. So let's suppose I'm just asking, what do you prefer? Do you prefer apples or do you prefer bananas? And you may say, well, you know, I prefer apples. Or someone else may say, no, I prefer bananas. Or alternatively, I could say, how about bananas and coconuts? Do you prefer bananas or do you prefer coconuts? And you might say, well, you know, I prefer bananas to coconuts. So one way we write down preferences or think about preferences is through revealed actions. So we can just give people sets of choices and ask them, which do you prefer over the other? So when you think about overall preferences, what we'd like to do is we'd like to have a complete listing of someone's preferences. So we'll talk about oftentimes what are called preference orderings, which are just a ranking of a whole set of alternatives. Now typically those alternatives will be within a particular class. So I'll have a preference ordering over fruit, I might have a preference ordering over vegetables, I could have a preference ordering over houses, over cars, right? So within a category, I can rank different things, all right? So we can then ask, well, how many preference orderings are there, right? So what does this thing look like? Well, let's suppose I've got these three things, apples, bananas, and coconuts. And I could say, okay, well, on apples and bananas, there's two possibilities, right? Either I prefer apples to bananas, right, which I'm going to show here with a greater than sign, or I could prefer bananas to apples. So there's two possibilities. Next, if I look at bananas and coconuts, right now I've got that I could prefer bananas to coconuts, or alternatively, I could prefer coconuts to bananas. So there's two possibilities there. And finally, with apples and coconuts, I can either prefer coconuts to apples or apples to coconuts, and there's two possibilities there. So 2 times 2 times 2, right, I've got to times these, is going to be 8. So there's 8 different ways, 8 different types of preferences I could have for these three types of fruit, right? So that's a lot of different things. And each one of them I can just represent by these sort of greater than signs, like which one I like first, you know, which one do I prefer? Now, there's a bit of a problem though with this. Let me erase all this for a second. There's a bit of a problem with this because let's look at these particular preferences. These preferences say, I prefer apples, right, to bananas. I prefer bananas to coconuts, and I prefer coconuts to apples. Now that doesn't make any sense, because if I prefer apples to bananas and bananas to coconuts, then I should prefer apples to coconuts, right? So this doesn't make any sense, and it should go like that. These are what we would call transitive preferences. So they satisfy a relationship called transitivity. So these are transitive preferences. And so we typically assume that individuals, that people have transitive preferences. Another way to think about transitive preferences is that they're rational. So it'd be irrational to say, oh, I like apples more than bananas, bananas more than coconuts, but coconuts more than apples. That doesn't make any sense. So we think of rational preferences as being preferences that are transitive. If I like A more than B and B more than C, then I also like A more than C. Okay? Well, then I can ask, if this is true, right, if apples bigger than bananas, bananas bigger than coconuts, if that implies apples more than coconuts, that puts a restriction on how many preferences I can have. I can no longer have anything. It rules certain things out. So now we can ask, how many preferences can I get that way? Well, this is actually also an easy calculation, and we've sort of done some of this math before. Well, it means there's going to be one thing I like best, right, that's ranked first, one thing I like second best, and one thing ranked third best. Well, so how many different things could I like first? I could like the apple, I could like the banana, or I could like the coconut. So I chose the apple. There was 3 possibilities. Once I've chosen the apple first, I've got 2 things I could choose next, the banana or the coconut. I choose the banana, but I could have chosen any one of 2. But once I get to the third thing, I've only got 1 thing left. So there's 3 times 2 times 1, which is 6. So there's only 6 ways to sort of have rational preferences over these 3 alternatives. So when we think about rational preferences, what we think of is these preference orderings, right, where one thing is preferred to the next is preferred to the next. Now in more sophisticated models, we can also allow equality, right? So I could say I'm indifferent between bananas and coconuts, but here we're just going to assume that you like one thing more than the next. So first thing we get, just in thinking about these preferences, is that if we impose some rationality assumption, like for people having preferences, then there's fewer preferences than we'd get if we just sort of allowed anything to go. So here's the game. Here's sort of what we're going to play with in this particular model. We want to think about, suppose I've got a bunch of people who have rational preferences. And now, suppose I want to ask, how do their preferences add up? What I mean by that is like that, okay, well, think about it. Each person has preferences. And now I can say, well, what is the society's preference? Or even like in a family, I could say everybody in our family has preferences over these fruits, right? Each member does. Well, can I say anything about the family's preferences? Well, first, notice if everybody has the same preferences, it's pretty easy. If everybody in the family likes apples and then bananas and then coconuts, then we can say, well, the family likes apples and then bananas and then coconuts. It gets tricky, right, if different people like different stuff. So if one of us likes apples and then bananas and then coconuts, but another person likes bananas and then coconuts and then apples. So if we differ in our orderings, now becomes somewhat problematic to decide, well, what is our collective ordering? What are our collective preferences? So this is an aggregation problem, right? We've got individuals with preferences, and now we want to ask, what's the collective preference? Well, here's what's really interesting. Let's watch. So here's some preferences. Person 1, right, here's person 1. They like apples and then bananas and coconuts. Person 2 likes bananas and then apples and then coconuts. And person 3 likes apples and bananas and then coconuts. Okay, so if we think about this, we think, okay, what are our collective preferences? Well, there's some diversity here in what we want, but it seems pretty clear that like coconuts should be last because everybody has coconuts last. So we'll put the little coconut here, right? That's in last place. Now it comes down to sort of apples versus bananas. Now one thing we could do is we could say, well, let's treat people equally. Let's not suppose that person 2 is somehow more important than person 1 or person 3. So if we treat people equally, and we could say, well, let's just vote. And if we vote, 2 people like apples and 1 person like bananas, so then we can put the little apple here. I'll do a really bad apple. That's going to be better than the banana. Right? That's a horrible looking banana. And that's going to be better than the coconut. So we can sort of say, okay, these are collective preferences. Apple, banana, coconut. Okay? That's pretty easy. Well, now let's go for something where the preferences are even a little bit more diverse. Now person 1 likes apples, bananas, coconuts. Person 2 likes bananas, coconuts, apples. And person 3 prefers coconuts to apples to bananas. Now we got to think, okay, well, what happens here? Doesn't seem to be any clear winner. Well, one thing we could do is we could say, well, let's just do a pairwise vote. So let's just, vote these things through. So let's first compare coconuts to apples. So if we have coconuts to apples, we notice that, and again, let's number these people 1, 2, and 3. If we do coconuts versus apples, we see that person 2 and person 3, right, prefer coconuts. So coconuts is going to win 2-1. If we look at coconuts versus bananas, we see that, person 1 and person 2 both prefer bananas to coconuts. So 1 and 2 prefer bananas, so bananas are going to win. So let's actually circle these. So coconut wins versus apples, and bananas win versus coconuts. So therefore, it would stand to reason that bananas should win with respect to apples, right? Because bananas are better than coconuts, coconuts are better than apples, so therefore, bananas should be better than coconuts. Well, let's check. Let's sort of just check to be sure. So if we compare apples to bananas, we see that person 1 likes apples more than bananas. Well, that's okay. Person 2 likes bananas more than apples, but person 3 likes apples more than bananas. So we get that 1 and 3, right, both prefer apples to bananas, so apples wins. Well, look at this. The group, here's the collective. Here's what the collective preferences are. So we can write this as collective preferences. The collective likes coconuts more than apples, apples more than bananas, and bananas more than coconuts. That's irrational. That's not transitive. So here's the really funky thing. We've got individuals. Every single individual is completely rational, right? They've got nice transitive preferences. There's no inconsistencies. But then when we vote, when we try and aggregate these preferences, we get something that's not inconsistent. So this is a paradox of aggregation. So before we talked about aggregation, we got things like, simple rules could create complex phenomena. Here what we're doing is saying, look, aggregation of preferences, aggregation of some structure can give us something that's it doesn't have one of the properties of the parts. So each part was rational, but the collective isn't rational. So this is formally called Condorcet Paradox. So each person is rational. Each person has rational preferences, but then when we vote, the collective is not rational. The collective says, if we go back, right, the collective says, oh yeah, coconuts versus apples, coconuts. Apples versus bananas, bananas. So then you think for sure they must like coconuts more than bananas. But in fact, if you have people vote, bananas will beat coconuts. So this is the Condorcet Paradox. Each person is rational. The collective is irrational. So this has some pretty severe implications. The implications are going to be that when we think about voting, that now suddenly we're not necessarily going to get a good outcome. We could get almost a random outcome. And then it means that people might want to vote strategically. So later on in the course, when we start constructing models of how people vote, this will be near the end of the course, we'll see that the fact that aggregation doesn't work, right, that there's a problem with aggregation in these over-preferences, that's going to create incentives, opportunities, conditions under which people might want to sort of manipulate agendas, lie about their preferences, or misrepresent their preferences in order to get outcomes that they want to get. So here's a case, right? Aggregation doesn't give us something we want. Okay? So again, just to drive this home, each person has totally sane, rational, transitive preferences, exactly what you'd expect. But when you look at the collective has this irrationality. So aggregation is sort of a funny thing. That's why social science, right, in particular, in this case, politics, is so darn interesting, right? Because what happens at the macro level is sort of logically inconsistent. Now we've seen aggregation in several forms, right? We've seen aggregation of numbers in the central limit theorem. We've seen aggregation of rules, right, in both the game of life in the one-dimensional cellular automaton. We saw how we could get really complicated things from simple parts. And now in looking at preferences, we've sort of said, well, let's look at aggregation of some other mathematical structure, namely these orderings. And we found that orderings that are, in a mathematical sense transitive, sort of the social sense rational, don't necessarily aggregate into orderings that are transitive and rational. So we get that we can lose logical consistency as we go up. So these sort of interesting aspects of aggregation are ideas we're going to play with throughout the course. Now, none of these particular models any real thing per se, right? But they're building blocks. They're giving us a basis for how to think. If nothing else, I hope these lectures are giving you some sense of like the mysteries and the intricacies of adding things up, and why the social world is very, very different than the parts that comprise it. Thank you.